This is question 8, test 7, section 3, page 770. So it says the table above shows how many students in a class of 12 preschoolers had 0, 1, 2, or 3 siblings. Later, a new student joined the class, and the average, arithmetic mean, number of siblings per student became equal to the median number of siblings per student. How many siblings did the new student have? So I do want to note that this is number 8 in the grid section, which means that for most of you, you should skip it. If you're not trying to get a score that's around 600 or higher, you should plan to skip number 8 in the grid section because it's one of the most difficult problems in the entire test. Because remember, in the grid section, the questions from 1 to 8 go easy to difficult, and then you're back to easy questions on question number 9, which is the first question in the grid section. So this is the hardest question among the multiple choice questions. Okay, so remember that median is not the same as mean. This is a visual to explain what the median means. So the median is saying that there are 50% of the students that would be below the median and 50% that would be above. This situation is a little complicated because there's 12 preschoolers in the class. So that means that you're going to have 5 students who have a number of siblings that's below the median. You're going to average the 2 students in the middle, and then you'll have 5 students that have a number of siblings that's higher than the median. So you'll add these 2 middle students and then divide the sum of their siblings. So I'm going to write this all out, and then I'll show you a shortcut that you could do. But I do think writing it out is very helpful for this one. So you'd want to write that there are 3 students who have 0 siblings. So you'd write 0, 0, 0. And then there are 6 students who have 1 sibling each. So you'd write 6 ones. 1, 2, 3, 4, 5, 6. There's 2 students who have 2 siblings each, so that's 2, 2. And there's 1 student who has 3 siblings. So this gives you your 12 total students. And like I said here, you're going to have 5, 1, 2, 3, 4, 5 of these students who will be below the median. So note that technically the median here is going to be the average of 1 plus 1 divided by 2, which is 1. So you can see these values aren't all necessarily below the median, but it just means that you have these students. There are 5 students who, when you list the terms from least to greatest, that they fall below the median here. Okay, and then you have 5 students to the right of the median, meaning they're greater than the median. And once again, you do actually indicate the ones repeating, since there are 6 total students who each have 1 sibling. A shortcut for this, and for many problems about the median, is to look at the chart. So you have 3 students who have 0 siblings, so that gets you to 3. And then within the 6, that's going to get you to the middle part right here, because you're going to get the 4th student and the 5th student having 6 siblings. So that gives you your 5 below. And that only takes up, it only takes up 2 of the slots for the students with 1 sibling each. You can think of it like this: 1, 2, 3, 4, 5, 6. And you have already taken care of 3 students here, and then you get rid of 2 of the students to bring you to 5 total. So then you're at your median. And you can count up from the bottom in the same way. So you've got your 1 student here for the bottom. Now you've got 3 total students for the bottom. And then you can start drawing upon these students who each have 1 sibling. So it's the same exact kind of thing. Now you're going to draw from these 2 students who each have 1 sibling. So then you have your median in the middle here. Since there's 12 terms, it's going to be the average of the 2 middle terms. Okay, so the median is 1. That means the median is 1 sibling per student. And then a student joins the class. So now the total number of students is 13. So remember, the average equals the sum of the terms divided by the number of terms. And we're told that when this 13th student joins the class, that then the number of siblings per student becomes equal to the median number of siblings per student. So this 13th student is added. And then we have this change in the equation. So what I would do is kind of brainstorm different ways this 13th student could have their siblings. So they could have 0, 1, 2, or 3 siblings. So let's just start from the beginning. If they have 0 siblings, let me make some room. So if they have 0 siblings, then you're going to add 0 to the total. And then when you add all the terms up, that gives you 13. So 13 would be the sum of the terms. And the number of terms is the number of students, and it's 13 students. So then the average becomes 1. And then we just have to double check and say, if the average is 1, then would all other pieces of the puzzle fall together? So the number of siblings that the new student has is 0. The number of siblings per student becomes equal to the median number of siblings per student. So that's the last part we have to check on. So if we throw this 0 into the mix, is the median number of siblings per student 1 still? It's very likely, because we're just going to add it down here now just so we can visualize the median. So now we have an odd number of terms, so our median will be perfectly in the middle. Whenever you have an odd number of terms, the median's just right smack dab in the middle. So you'll have 6 terms below the median, so that'll be 1, 2, 3, 4, 5, 6. And you'll have 6 terms above the median, which you have here. So then the median is 1, and now everything works with our problem. The median is 1, the average is 1, and then we just have to make sure we're answering what they're asking. They want to know how many siblings would this 13th student have. They'd have 0 siblings.